let's look at polarization and the reflection and refraction of light. What we know so far is that whenever a beam of light strikes the interface between two surfaces, that beam of light will be reflected and refracted. And so let's look at just a little picture of this. If this is the interface between medium with index of refraction N1 and N2, and then we have a beam of light that strikes the interface, then we know that it will be reflected so that the angle of incidence is equal to the angle of reflection, and it also will be refracted. So let's say that it goes this way, and we would have to use Snell's law to figure out this new angle, the angle of refraction. So this is what I mean by, a beam of light will reflect and refract at the interface between two surfaces. Now, when that incident beam strikes the interface at a particular angle, two things happen. Here is the first thing. So let me draw again the interface and the incident beam. So if this angle is, like I said, a special angle, a particular angle, then when the beam reflects, it will reflect so that this reflected beam will be polarized. So let's draw, I guess, let's see, the orientation of the electric fields of the original beam of light. So we'll say that this light is unpolarized, and once it reflects at this angle, we have the light being polarized. So we're starting out with light that is unpolarized, meaning that the electric fields of the light fluctuate sinusoidally, but in every which direction. The light beam strikes the surface, and when it reflects, only one direction of electric fields will be reflected. So you only see the polarized light. So this is one thing that happens under this special angle. The other thing is that the refracted beam is at right angles with the reflected beam. So let's draw that again. Here we have the interface. So we have index of refraction N1 and N2. We have the incident beam that is going to be reflected, and this is the refracted beam. So we start out with light that is unpolarized, so the electric field lines are every which way. They undergo reflection for this special angle, at a special angle. So we know that that angle actually is the same as that, right? Because the angle of incidence equals the angle of reflection. And then we end up with polarized light from the reflection. But now the new special thing is that the angle of reflection, the reflected beam and the refracted beam are at right angles with respect to one another. So the reflected beam here and the refracted beam are perpendicular to one another. So again, when this angle is a special angle, the incident light that was unpolarized will become polarized due to reflection, and the reflected beam and the refracted beam are perpendicular to one another. This angle of incidence, this special angle of incidence, is called the Brewster angle. And the symbol for it is just theta sub b for Brewster, and tangent theta sub b is index of refraction of the second medium divided by index of refraction of the first medium. So let me draw this one more time. Incident beam of unpolarized light reflects and light here is going to be polarized. This is the Brewster angle, and also the refracted beam and the reflected beam are at right angles to one another. So the first medium has index of refraction n1, the second medium has index of refraction n2. So tangent of this angle theta b is index of refraction n2 divided by index of refraction n1.